Okay, welcome to Automated Deployment. Today's speaker, Mauricio Tavares, is a Linux and Network Systems Administrator at the Renaissance Computing Institute at the University of North Carolina at Chapel Hill. He's currently involved with Chameleon Cloud and Enter, enabling network research and the evolution of a next-generation mid-scale research infrastructure. Previous webinars have shown how to automate the orchestration of an experiment, from allocating the resources to building the lab to running the experiment and tearing it all down using heat templates. Chameleon is a research platform in which experimenters can make on-demand or advanced reservations for resources. Some experiments require resources, GPUs, FPGAs, that are both scarce and popular, so users must reserve them well in advance. Other experiments require large portions of the test bed and are ideally scheduled during off-peak times. In all cases, efficient use of allocated resources requires experiments to start as soon as the reservation becomes active. It is often difficult for users to be physically available to start an experiment for reservations made far in the future or during off-peak hours. This webinar will demonstrate how to use heat templates to automatically deploy experiments when a reservation becomes active. We will use Chameleon's new automatic deployment mechanism to start a reservation and deploy the experiment without human intervention. It will last about 45 minutes with time for questions at the end. During the presentation, please type general questions in the Q&A box. Members of the Chameleon team are on the webinar and will be answering your questions. Thank you and welcome, Mauricio.
Thank you. So, as it was just mentioned, on the previous webinars, we started with how to use Chameleon Cloud, and then how to use the Jupyter notebook, and then we kept going on adding more and more automation and less user interaction, because we really want to cut down the time that the user needs to spool up the environment, the lab, and have more time actually doing the experiment. Now, the thing we didn't do until now was automate the actual scheduling of the entire experiment. And that's going to be the goal for this experiment, this presentation today. So, okay, you go away. So, first of all, if you remember on the, let's make this very big. If you remember on our previous webinars, we had, the last one we did was on heat template. And now I suggest, if you haven't gone over that heat template webinar, you really should go to it, because we're going to be building upon it. You can go here on the webinars and look for them, and also some of our documentation. But right now, we are going to go to our Jupyter interface, which usually you get from here, and use the notebook we're going to be using, called Automated Deployment. And it's here. So, first of all, what we're going to do, usually we do in one single script, but we're going to break it down into specific steps so we can show how each process is being done. Now, if you remember in previous webinars, I kept using a same lab experiment, which if you use the power of Sharpie, this is how it looks like. So we have 3 hosts. One I call the external server, and 2 iPerf machines, iPerf server and iPerf client. The external server is the one we have access to. And the iPerf machines, they are going to start, we are going to install the program iPerf to do some network performance testing, and which will going to be, the experiment is going to be run on the iPerf client, which will be connected to the iPerf server. The iPerf client will save the output from this experiment into a file. And then after that, the external server, the one we have access to, is going to be used to retrieve that output. So to do that, we first start really with our usual creating some basic variables, same things we have done before. So I can make this a bit easier to read. So as here, it's like we have a list name, stack name. Stacks were defined, what we mean by stacks were defined on the Hit template notebook and webinar. And as before, we're going to have 3 nodes: the external server, the iPerf server, and the iPerf client. I'm going to be using the SSH key that I created that's called my username -Jupiter, which I already have loaded into Chameleon. If you forgot how to do that, there's you can click here and go back to see how that was done. Okay, so step 1, what we need to do is install those Python libraries, which are required to do our little magic. And you can just click here. As I said, all this should be done in one single bash file, but we're being steppy, so we can show each step. Then we get the old iperf.yml, the Hit template that we created for the Hit template webinar. I decided not to be very original. Here we got it. Let's take a look at it. Yep. Okay, here's how it looks like. We have a little description, some parameters that, if you remember, if we start this Hit template from within Chameleon, we can enter those arguments using the GUI. So you can do some customization. But we are doing this from command line, so we have to have a way to provide that. And those are the parameters that we have defined here: key name, reservation, image name, flavor name, private network name, and IP subnet. And here they are. Some of those have a default value. And I'm going to let most of them use a default value. For instance, I'm going to let it run CentOS 7, even though probably we should be doing CentOS 8. But you know, for this experiment, it doesn't matter. The only thing I'm going to active feed to this when I created my stack is the key pair. And that's me providing the key pair. And just the output. So I initialize a stack, and That's the output showing that it has been initialized. And let's see I cheated. I created this stack half an hour ago. So, but let's assume I just created. So we're not going to be wasting time waiting for my 3 machines to start. Now that we did that, we are going to actually call the hit template and starts pulling up our lab. If we go back here, you're going to see that my start date, I told it start today, right now, but actually 5 minutes in the future from right now, and end it 1 day from now. So if you ran this, it's going to show an output like this, status pending, and will not show any server being created because it needs to wait 5 minutes before it actually starts the experiment. If you're going to run this in a real environment, you're probably going to say that, okay, I want to create my experiment, say 2 weeks from now at 3 o'clock in the afternoon. And then you go to our start date and add it for that. And the end date, you can say, okay, like I need 1 week. So you add 1 week from there. Now, everything else should be very similar to what we have done before when we create leases from the command line. So we have how many nodes we're going to use. I'm getting 1 node plus 1 just in case if one breaks on me. And then off we go. So as we're starting it, this is the part I'm going to do some cheating. You're going to see it first going to start saying 1 machine is being built. And then if you run again OpenStack server list, 1 machine finally gets active, 1 server or instance finally gets active and then goes to the second one. And then once the second one is done, and then it starts building the third one. Why that is done? Because that's how we specified on our hit template. We actually define an order. 1 machine has to wait on the other one. And the first one is the external server. And then the IPF server and the IPF client. As we covered last webinar. Now, once all 3 servers are created, you're going to notice that the external server is going to also have assigned its static IP. And I did here, as you can see, I checked to see if I could connect to it, and yes, I can connect to it. But just to be on the safe side, I'm also going to do it from within the script, because on step 4, we should by now have run the experiment. And the experiment, you remember, it runs only between the iperf serve and iperf client. The external server is being used for nothing else but to access the experiment and retrieve the data. So here, I'm getting the information about the external server. This node name is actually the name of the machine you're going to be connecting to. I could have used the IP, but if you remember on the iperf.yml, one of the things we did is we are here. We are creating, we are populating the etc. host file inside the external server with the IPs for the iperf server and client. So I thought, hey, you know, why not use it? So before we use that, we do need to do this step to wait until we can connect to the external server. And then we need to put our key, make our key available, because we're going to use the external server to connect to the iPerf client. And then we are this single line actually is used to SSH to the iPerf client using the external server as a jump server and get the results file that we created. So this is the output. I can run it again. And as you see, it's using my Jupyter file username -Jupyter key. And that's the output that's currently on the iPerf server. Let's run it again, just because. The part that's taking time is this loop here, because you see first it waits 30 seconds before it does this check. So why is doing that? Actually, let's wait 30 seconds. There it is. So incidentally, this is also a way to show that something we mentioned before, that we can use Jupyter notebooks not only to write instructions, run commands, but also store results. And here it is. We run the command. Here's the result. If I want, I can just copy this, put somewhere else, or just, if this using as a training class, there's the result. If you're using just for a experiment, instead of getting the result, you could just have used, instead of SSH, you could just have used SCP and copy the file to the either just the machine that we're running, the Jupyter notebook, which doesn't have much space, or if you had provided a host name, an IP, and a way to connect you, we could have copied straight to the machine that you have lots of storage, and then put it there so you can do some post-processing and pretty graphs and something. So let's see. Let me do some clear screen. Open stack. Up. Stack list. See, that's the only stack we have. And I think you probably noticed that, you know, this is a very quick webinar. And the reason is that we're not doing the work. If you note, all I had to do is click, run, and then here I have the result. I didn't have to enter any data or provide any information. And as I said, if you had copied this, that, you know, out those three guys here, that, and this, and then that to one file, you could have run it, would have written this to the screen, and then this final command will destroy the entire experiment. So, any questions?
It looks like we have a question from Eric. Is there an archive available for the previous webinar on heat templates?
Yes. It should be, I honestly don't know how to get to it, but there's a way around it. You know, if you want to cheat, you go here, chameleoncloud.org, you hit blog, and there's this one here, choosing the right orchestration in Chameleon. And if you scroll down, here we are comparing all the different ways to orchestrate things. And here's the link for the Hit Templates webinar. Also, if you go here to your Chameleon, your Jupyter notebook, you're going to see here, Hit Orchestration, and you double click it. This is the notebook we use in that class. So you can just do what I'm doing here, click on it, here's a and you see like here, simple template, not so simple template. And we talk over about the different things we're doing on that Jupyter not Jupyter notebook, but on the Hit template. So that's what I would suggest you. Go here to the blog, find here webinar under 4 Hit templates, and then you click it. I right clicked, there it is. We probably, let's see one thing here. Okay. We probably should make a link here so we can get to the other one too, but to the documentation. And here is the notebook for the Hit templates. Okay, next question. Also, one other thing, when we do the OpenStack stack delete, we're going to delete the network, the 3 servers, release the floating IP that we're using to connect to here, which is this IP here. We're going to release it so somebody else can use, kill all those 3 servers, and then get rid of the lease, and then get rid of the stack. All that is done by that single command, which that's how I like things to be. I'm kind of procrastinating to run it until there's no more questions.
I don't see any additional questions coming in right now.
Okay. Now, if someone wants to play with this, I suggest we could, things I would have done different here if you want something as an interesting exercise. All those 3 servers are using the same image. And there's nothing stopping you from having each of those use a different image here. All we have to do is define those parameters here. Instead of just one image name, you can define like 3 image names and then make the default whatever. And then so people can customize, make all them like, you know, maybe one is Fedora, the other is Red Hat, the other is Ubuntu. If they have a FreeBSD, maybe FreeBSD. If they don't, oh well. And whatever. So Any more questions? If
Okay, I don't see any more questions rolling in right now, but thank you so much, Mauricio, for presenting this talk today. We appreciate your time and that of our attendees. Thank you all and have a wonderful rest of the day.